When solving radical equations, your goal is to isolate the radical. We're going to do this because then we can take the square of both sides or the cube, we can undo the radical. So this is your goal, and the reason why I start with the goal is because I'm going to show you 4 different practice problems, but they all could look different in some fashion, but the consistency with all 4 of these problems is the fact that I will isolate the radical so then I can undo the radical. So looking at example 1, the one thing that I need to do first to get the radical by itself is subtract 1 from both sides. So then I'm left with the square root of x minus 2, and that stays together since it's under the radical, and now it equals 4. So now that it's isolated, what I can do now is take the square of both sides. So on the left-hand side, that cancels out the radical, and we're just left with x minus 2, and then 4 squared is 16. So then we just solve the rest of the problem like the linear problem it is, and we get x equals 18. Now, you need to check to make sure that your radical, that the solution to your radical equation is correct. And it's not just to check that it's correct, it's to check that you get the right answer, because when we take the square root of numbers, we can have a plus and minus, and we can't take the square root of a negative because we're not dealing with complex numbers now. So you have to check for a couple of those things. So for my check, I'm going to plug back in 18 where I had x. So 18 minus 2 is 16. The square root of 16 is 4. So 4 plus 1 does equal 5. So we did this one correct. So for number 2, our radical is already isolated, so we can start by squaring both sides. And what makes this one different is the fact that we have a quadratic underneath. So I'm left with x squared minus 21, and 10 squared is 100. So I'm going to add 21 to both sides, and I get x squared is equal to 121. So now we need to take the square root of both sides, and now we have x equals plus 11 and minus 11. So we need to check. Alright, so I need to check each one at a time. So I have positive 11, squared, minus 21. Okay, so positive 11 squared is 121 minus 21, and we get 100. The square root of 100 is 10, so positive 11 worked. So now we need to check negative 11. So we have negative 11 squared minus 21. Now a negative times a negative is a positive, so we have 121 minus 21 equals 10, which is 100, and the square root of 100 does equal 10. So this is an example of where you have 2 solutions. Okay, in problem 3, again, our radical is isolated. So we're going to start just by squaring both sides. And when I do that, I get x squared is equal to 7x plus 8. Again, this is a quadratic, so to solve it, we're going to set it equal to 0 and bring everything on the left-hand side so that a stays positive. So we get x squared minus 7x minus 8. So we're going to ask ourselves if we can factor, which we can. So what multiplies to give you negative 8, that adds to give you negative 7. And I get negative 8 and positive 1. So that means my two factors, or those are my factors, my two solutions are 8 and negative 1. But now we need to check both of them. So if I use 8 first, then 8 should equal the square root of 7 times 8 plus 8. So 7 times 8 is 56. So I get 8 equal to the square root of 56 plus 8. 56 plus 8 is 64, and the square root of 64 equals 8. So that means 8 is good. Now let's check negative 1. So negative 1 equals the square root of 7 times negative 1 plus 8. 7 times negative 1 is negative 7. Negative 7 plus 8 is 1. And the square root of 1 does not equal negative 1, it equals positive 1. So that means that 8 works, however, negative 1 does not. Our last problem, number 4, the radical is isolated, so the first thing I can do is square both sides. Now, watch how I'm putting parentheses every time I do this because it's going to matter on the right side when we simplify. So we get 4x minus 15 equals to x minus 3 times x minus 3. So write it out and double distribute so that we know we get exactly what we should. And this gives us x squared minus 6x plus 9. So once again, we're going to set it equal to 0, bring everything to the right side, and I get x squared minus 10x plus 24. This is also factorable, and we get x minus 6 and x minus 4. So our solutions are positive 6 and positive 4. So now let's check. So we have the square root of 4 times 6 minus 15 equal to 6 minus 3. So that is the square root of 24 minus 15 equal to 3. 24 minus 15 is 9, and the square root of 9 does equal 3. And then we do also have to check 4. So I have 4 times 4 minus 15 equal to 4 minus 3. 4 times 4 is 16. So I have 16 minus 5 under the radical equal to 1. 16 minus 5 is 1. And then we all know that the square root of 1 is 1. So this is also correct. So that means both of 6 and 4 are my correct solutions. So remember, if things are in front, outside, or being divided by your radical, you need to first isolate the radical so that you can perform the exponent or the power that undoes that given radical. Then you need to solve it from there, whether it's a quadratic or a linear function, but then you have to check. You have to make sure that after you take the square root, you get what you were supposed to get on both sides and that they're set equal to one another.